The bear, an animal that has fascinated man since the dawn of time. It has been hunted, rejected, humiliated as a fairground attraction, and in some cases, driven to the brink of extinction. However, the early humans feared its strength, worshipping this animal capable of standing upright like a man. While resembling it in so many ways, is our fascination for this mammal due to its ability to hibernate.
In summer, bears behave like any other active mammal, but in winter, they go into hibernation mode and adopt a new biological function that's conducive to self-protection.
For 6 months, the bear lives in a state of lethargy as its organs switch to a very particular operational mode. First, the heart slows down. Then the kidneys cease to evacuate waste. Muscles and skeleton go to sleep. All these measures allow the bear to preserve its entire body until spring, when it will emerge from its den in perfect health.
There he is, by the felling area.
Out in the field, an international team is eager to unlock the secrets of this incredible resistance and understand the physical changes that occur during the bear's hibernation.
The next step is to identify the mechanisms and perhaps the single molecules responsible for the protective mechanisms.
This new generation of researchers believes that solving these riddles could revolutionize medicine.
Nature has developed its own solutions, and by exploring them, we hope to harness them for use in the human species.
Can the bear inspire mankind to discover new therapies? Takesen, in the north of Sweden. Brown bears, or grizzlies, have roamed this wilderness for thousands of years. In mid-February, the 3,000 bears populating this territory hibernate in their dens beneath the pines and huge larches of the boreal forest. Since 1984, a team of rangers and veterinarians has been observing brown bear populations throughout Scandinavia in an assignment called the Scandinavian Brown Bear Project. They are studying the behavior of bears in their natural environment. This morning, they are escorting a very special team of scientists. These biologists and doctors are neglecting their usual patients for a few days in an effort to untangle the mystery of bears' resistance during periods of inactivity. The pioneer of this research is a Danish cardiologist named Ole Frobert.
Yeah, now we're in the middle of all of it, how it all started, that we go now out to the forests to locate the bears and take samples from them. And the whole purpose of this endeavor is to see how is the bear's physiology in winter compared to how it is in summer.
In sub-zero temperatures of minus 20 degrees centigrade, the scientists venture off-road. They're following a GPS signal emitted from a 2-year-old bear hidden somewhere in this huge forest. Once close to the den, the team cuts the engines at a safe distance and dons snowshoes to venture into the taiga. One of the veterinarians tracks down the source of the signal. Field leader Sven Brunberg knows it is close. They have located the bear. The den is here. This small cavity serves as a refuge for the bear throughout the winter. The fresh snow protects it and remains porous enough to allow the animal to breathe. Jon is ready with his anesthetic darts. The rangers have to act fast. The bear is not completely asleep, even in full hibernation. If it hears a shovel or a fly enters its den, it may suddenly wake up and run away, smashing everything in his path.
We have done that so many times, so we know how to do and how we should approach that. And all person had an own function, so we know exactly what to do.
"15 minutes later, the anesthetic has taken effect. A strange medical ballet then gets underway in the middle of the Swedish taiga. The scientists have little time to collect samples and package them. The bear cannot be kept out of its den for more than an hour, especially at this temperature. The bear's whole body is closely examined. Kidneys, bones, muscles, and heart are all enigmas for the scientists to solve. The samples and biopsies required for their research are taken by veterinarians, who are the only ones allowed to handle the sleeping animal.
But it's always a challenge to get the blood in winter. Almost hyperventilated.
Danish cardiologist Peter Godsk has been interested in Ole Frobert's work for several years. Both know that in winter, the bear's heart slows almost to the point of cardiac failure. And yet, in just a few months' time, the heart of this bear will be perfectly healthy, working at full capacity. Peter is eager to learn more about the mechanisms of this remission.
Which is interesting because how does the bear adapt to the conditions during the hibernation?
The way the heart moves, it looks like a patient with heart failure. But when we come and disturb the bears in winter, they are alert and they have no signs of heart failure at all. And we want to learn from that downregulation.
Today it's so cold that Peter's equipment is not working.
Shit. They're dead. Yeah. It's very disappointing. The fact that there's no battery on the machine is really disappointing for me because, of course, there's a lot of effort that's been put into this, and now it's just not working. And yeah. It's really disappointing, of course.
Tell me when you start the incision.
Yes.
Fabrice Bertil and Etienne Lefay are two French biologists who are interested in another mystery. How do bears manage to prevent muscle wastage while lying inactive for 6 months? To understand this phenomenon, they take biopsies of the bear's muscles and samples of fat tissue.
Etienne?
Yes?
I have some fat for you. Will that be enough?
Perfect. Don't forget the skin.
Good, that's enough.
The analysis of these samples could revolutionize the lives of millions of people around the world suffering from muscular atrophy. People rendered inactive by old age, hospitalization, or ill health could all benefit. Even astronauts whose muscles waste away in weightlessness.
It must be freezing there.
Maybe we'll put the tubes in our pockets.
Shall we keep them on us?
I think so, yes. And a monitor with the temperature sensor.
I still have a couple of samples to take. We're a little bothered by the cold, which is worse than usual, and samples must be processed very quickly before they freeze. So that's just a small problem. The skin is okay?
Yes, it's here.
That was a close call. Sizzling. Well, not exactly hot, but...
An hour has passed. Time to return the bear to its den.
We have here a team of experts who can handle all these difficult aspects with the bear, veterinary medicine, controlling their physiology, rangers that can dig the bears out without hurting them.
34.5.
To avoid disturbing their biology, the bears chosen for this research are not yet old enough to reproduce. They will only be subjected to 2 sampling sessions during their lifetime, one in winter and another in the summer of the same year. The 50 bears already studied seemed unaffected by these medical interventions. They have all resumed a natural hibernation cycle, feed well, and reproduce normally. Every spring, the bear wakes up unscathed to resume its cycle of activity. The animal is seemingly unaffected by a period of immobility that would be crippling for humans. This is precisely what Peter Gosk is trying to understand through his research on bears.
You did the same tests on bears?
That's right, we examine their cardiac activity. We study it.
What's a bear's pulse?
That's what's so interesting. During the summer months, it's similar to humans, but in winter, it drops considerably, falling to around 20 to 25 per minute, with long breaks.
So there are long breaks.
Exactly. A few years ago, devices were put in place to monitor their heart rate. In the case of one bear, its heart stopped beating for 19 seconds.
Good grief.
It's possible for bears, but the human heart can't stop for so long without causing fainting. Heart rate is sometimes disrupted too.
Yes. That's why I've been under observation since Monday.
Exactly. To check that your heart rate is good. Everything's in order. Now I'll set you free.
In Copenhagen, at the hospital where he works, between consultations, Peter Gosk studies ultrasound scans taken from bears in Takasund. The results continue to fascinate him.
Left side, you can see the heart from a bear during the active state, that is during the summer time. And on your right side, you can see an image of a bear heart from winter time or during hibernation. If the heart on the right side would be a human heart, I would be very worried for a number of reasons. First, mainly because the heart rate is really slow. In humans, we know that that would induce cardiac arrhythmias, or there would be a high risk of inducing that, and that could lead to sudden cardiac death. If you look here, is as this blood flowing, and you can see how it turns and goes like this. This is what medical doctors would call smoke. And when you have this smoke in humans, that's something we only see when you have some kind of cardiac pathology. We know that smoke is like a precursor for a clot or thrombus formation.
In humans, a combination of poor diet and sedentary lifestyle leads to the formation of clots in the arteries, which may cause myocardial infarction or a stroke. To thin the blood and prevent the formation of these clots, patients at risk are prescribed anticoagulants. Bears, however, do not need them.
We have some results previously showing that the blood is changing from summer to winter, so some kind of adaptation or change is going on in the bear during hibernation. What's one of the theories? The bears are able to change the clotting system so that it's more difficult for the blood to clot during hibernation.
Bears seem to be able to produce natural anticoagulants during winter to protect the body from the dramatic consequences of arrhythmias or slow heartbeat. At Örebro Hospital in Sweden, Olof Frobert has returned to his cardiology department after his adventures in Takasund. He carries out hundreds of cardiac operations every year on his patients.
Cardiovascular disease is still the most prevalent of the killer diseases. It's still killing more people than cancer. We think that the increase is very much related to a sedentary lifestyle, that people do not move so much. They are physically inactive, and that obesity is going up, so is diabetes. Okay, bro.
Okay, we're done.
Yes.
Bears are unique animals, especially interesting because they are quite close to us. If you look at the development, the genetic closeness.
Hi, Ole. How's it going?
And here the brown bear comes into our focus. It's highly obese. It doesn't move at all for 6 months. It should have cardiovascular disease, but it's a healthy animal, no cardiovascular disease, no diabetes.
The genetic similarities between bears and humans encourage scientists to examine how bears put their organs to sleep in the winter, and more importantly, how they reactivate them in the spring. The recovery of vital functions is particularly impressive in the kidneys. The kidney acts as a filter, purging the blood of its toxins and waste and evacuating them in urine. We know that hibernating bears neither defecate nor urinate, and therefore cannot purge the blood of its waste and toxins. How do they survive? Peter Stenvinkel, a Swedish doctor and kidney specialist, comes to meet Ron Kirstania, who has been studying black bear kidneys in Maine for several years in the United States. In this region, where bear hunting is allowed, Ron has been able to recover a number of organs from local trappers. Ron leads Peter to his laboratory to show him a section of a bear's kidney at the end of hibernation.
So here we have a couple of samples that we collected. So we paraffin embed them so that we can just then cut them. We can look at the structure of the kidney. So under the microscope is a sample of a spring bear. So you can take a look and look at the structure of the kidneys.
Oh yeah. I see two glomeruli that looks quite healthy, but the tubuli are changed. So there seems to be some kind of detachment here from the basal membrane, yeah?
Yeah.
This section of the kidney shows abnormal structure and cells that seem to be very damaged.
Amazing. I had never seen anything like this, and it will be for sure interesting to look more into detail what factors can cause this detachment.
And not only what causes it, but also how does it get back to normal?
Yeah.
Because, I mean, as I said, we don't see this in foal bears, so it means that this somehow gets restored.
Yeah.
And so it will be really interesting to see what genes, what proteins play a role in this process.
Yeah.
To learn more, the Jackson Laboratory team has sequenced the genome of the bears.
Your studies in bear kidneys looking at gene expression, could they kind of give us some kind of clue what is happening here during the winter sleep?
So what we see in the gene expression in the bears in the spring is that instead of having an increase in the expression of inflammatory genes like we see in human patients, we see an increase in genes that seem to be able to suppress inflammation.
Inflammation is a natural reaction of the body, activating the immune system to destroy diseased cells. Under normal circumstances, cells as badly damaged as those in the hibernating bear kidney should be destroyed, but they're not. The bear somehow manages to preserve its diseased cells by blocking inflammatory reaction. Ron's team now wants to experiment with this extraordinary faculty on mice that have been genetically modified to deprive them of their inflammatory functions. To this end, he places the mouse's kidneys in a state of asphyxiation.
We mimic what happens during hibernation. And then after 4 weeks, we look at these kidneys and then we see whether that indeed has a beneficial effect. If that's the case, then we could use that to develop new therapies that could be used in humans.
It's yet another amazing discovery about the bear. One that researchers hope will someday provide relief to millions of people who suffer from malfunctioning kidneys. Back in Sweden, Peter looks up his nephrologist colleague, Matthias Harhaus. Kidney failure causes premature aging of the body, which also weakens the skeleton. That is why these kidney specialists are also interested in bone structure variations in bears hunted at different times of the year. They measure bone hardness using a method called microindentation.
Does it work as well in the field with anesthetized bears?
Yes, we used it on hibernating bears. Okay, we have a value. Bone hardness here is 79.2. I measured bone hardness on bears during hibernation and again in active periods during the summer. We see a large seasonal variation. A bear's bones are harder during hibernation compared to their active period.
This hardness of the bear's bones in winter surprises scientists because, contrary to what one might think, bone tissue is generally supple, thanks to permanent renewal of its structure. The bone is a living tissue. In a healthy body, old cells are regularly destroyed while new cells are produced. This is known as bone balance. But bears' bones harden during the winter, proving there is no new supply of cells, as if this process of destruction and reconstruction has been stopped. This is how the bear preserves its skeleton while inactive. In comparison, humans bedridden or inactive for 6 months lose 30% of their bone mass.
This could help us understand the bear's immunity from the serious bone diseases that affect humans.
Absolutely. And it would be interesting to direct this research around the hip joints, where fractures due to osteoporosis in humans are most frequent.
Osteoporosis is a disease that appears when bone balance is out of kilter. The destructive processes take precedence over reconstruction, which results in a weakening of the entire skeleton. The next stage in this study is to observe bone growth in bears that are alive and well. Torkel Brisma, a radiologist at the Karolinska Institute, performs scans on bears in a wildlife park in the north of Sweden. Using this technique, he can study the skeletons of bears several times a year and compare developments in their structure. This high-tech scanner, usually used on human patients, takes snapshots to an accuracy of 0.2 millimeters to create a full 3D reconstruction of the skeleton. Journeying through these spectacular images helps Torkel understand why the bones of the bear are unaffected by osteoporosis. Back at the Institute, Torkel and engineer Rodrigo Moreno study the data collected on a growing bear.
You can see the growth plate here, where all the bones grows more, so it looks like this. Then we would like to have measurements like this area, but actually Garbo is one of the older bears, so I think she's 4 years old. So I would like a box like here, so we can evaluate trabecular bone, what it looks like, and then we analyze also the thickness of the cortical bone out here.
After compiling the results of this study conducted on 6 bears, the two scientists draw their conclusions.
In August, the results from thickness are interesting. There is an increase of the cortical thickness. That is, could be up to 1 millimeter. That is a lot.
Distance between here.
Exactly.
This increase in the thickness of the outer layer of bones in summer, a characteristic of growth, reflects a recovery of the bone-building processes that lie dormant during hibernation. If scientists could successfully activate this bone balance mechanism in humans, it would be a huge step towards the treatment of diseases related to sedentary and aging populations. Meanwhile, in Sweden, the bears followed by the Scandinavian brown bear project have been out of hibernation for several weeks.
It would be nice if we could get down there. A little more to the right. That way.
All welcome to this bear capture for
It's June, and a new important event is taking place in Takasund, where the international team of heart, kidney, bone and muscle specialists has gathered for 3 days to collect precious samples from their favorite animal.
Before this season, that is 4 bear we should take. The plan was that we take first Mike over passing up the Koskjord to Emosjön, and then we go south for Korpmäki.
These are the same bears in the same forest as last winter, but approach and capture methods are now radically different.
There he is, by the felling area, on the left.
He's running to the felling area. You see? It's possible. The wind's behind us. You have to be right above. Now, on your left.
Maintaining radio contact, the rest of the team moves in on the intervention site. The team takes Maiko into the shade before starting work. The scientists are moved by the sight of the bear they monitored last winter. But as always, time is short before the anesthetic wears off.
Holly, you want the ice box for a skin sample? Andrea, you would take this?
Working rapidly and thoroughly, the scientists set up their equipment around Maiko. Comparing the samples taken this season with those obtained in February will give them greater insight into the duality of the animal.
Etienne, should I give you a bit more?
Yeah, great.
I think that'll be enough.
Fine.
Yeah, it's fine. Perfect, thanks.
Afterwards, we'll take a little fat from elsewhere.
Okay. The feces?
We have some fecal matter here.
We'll put a bit more.
As expected, the ultrasounds show that Maiko's heart, seemingly failing during the winter, is now perfectly normal.
Beautiful pigs. So these are, of course, very healthy individuals.
At the same time, the veterinarians take measurements to check on Maiko's growth. This bear like the 543 others studied in the program since 1984, will be followed until the end of its life. After losing 1/3 of his body weight during hibernation, the young male has been growing well. Veterinarians attribute this to a healthy environment and to the abundance of resources. In a few minutes, Maiko will regain consciousness from his artificial sleep and resume his main objective for the season, accumulating as much fat as possible in preparation for the next hibernation. To that end, the animal will eat mainly proteins, such as insects, roots, meats, oily fish, and lots of very sweet fruit. Despite this weight gain, bears do not suffer any of the pathologies associated with obesity. Such rapid growth in a human would have dramatic consequences for the body.
One of the challenges for human heart disease is high lipids, high cholesterol, and how to avoid atherosclerosis, the narrowing of the arteries. And the bears, they have high cholesterol and no narrowings. We don't really know why. We're trying to explore this. What we know about the bears is that they have a very special diet. They switch from mainly meat-based diet in early and later summer to a more or almost exclusively vegetarian diet in winter.
Ole Frobert believes that the huge amount of red berries eaten by bears in autumn has a protective effect against the accumulation of bad fats and the development of cardiovascular disease. Could this diet have the same effect in humans? A widespread study of coronary patients is now underway.
We gave blueberry powder for 2 months to half of the patients, and the other patients just had their standard of care. And what we saw actually was that the blueberries lowered cholesterol in the patients. So blueberries improved lipids or cholesterol in humans.
Early results suggest this may warrant further investigation in the quest to develop more effective treatment of cardiovascular disease. A sedentary lifestyle affects not only the heart, it impacts all the other muscles of the body as well.
When you're inactive, maybe because of a sedentary lifestyle or because your movements are hindered for pathological reasons such as bad health or being elderly or bedridden, then your muscles will begin to waste away. This is called muscular atrophy, and it is a very serious condition because muscles not only allow you to move, they also serve to ensure vital bodily functions. Without muscle, you will become very sick. What is quite remarkable is that in the wild there exists a natural pattern of inactivity that does not lead to muscle loss. And that model is the hibernating bear. Like other mammals, it reproduces in summer, whereas in winter, although inactive, unlike man, muscle loss in bears is extremely minimal.
To understand this mystery, Fabrice Bertil begins to analyze the muscle samples taken from bears during the recent scientific assignment in Sweden.
This is bear muscle. 2 summer samples were taken, along with 2 winter samples. The idea is to crush them and reduce them to powder in order to facilitate the extraction of all the proteins contained within the samples, then analyze them via mass spectrometry.
Right, let's go. We have a beautiful powder.
Perfect.
Will the researchers find any difference between the muscle samples taken in the summer and those taken in winter?
So each little dot is what we call a protein spot filled with protein.
By comparing muscle composition according to the seasons, researchers have observed that some proteins appear in larger quantities in winter. One such protein is known to slow down the breakdown of muscle tissue.
In winter specimens, the signal is much more intense than it is for summer specimens. There really is a sharp break between the two seasons.
Yes, there is.
In any case, it gives pretty clear answers, so I'm pleased with that.
It's good.
I hope they're all like that.
Yes.
Bears do not feed or exercise during hibernation, yet their muscles do not atrophy, which is a real paradox. For the Strasbourg team, everything seems to indicate that this bear can adjust its muscular balance in the same way it does for its bones.
The question that arises is, how do bears manage in winter to preserve their functions? We're trying to identify which elements might be responsible for these beneficial effects on tissue, particularly in muscles. One way is to take some bear serum, bring it into contact with muscle cells, and then see if the beneficial effects of this serum transmit to a bear's muscle cells during hibernation.
At the Carmen Laboratory in Lyon, Etienne Lefay's team was eager to test the effect of bear serum, i.e., blood freed from its cells, on human tissue. To carry out this experiment, they grow human muscle cells in the laboratory before introducing the serum to them.
I'll show you the cells.
Where are we now?
Number 406.
406. This is the one that's changed since last week.
There, I finished the little video I made for you. It's really good.
This is perfect for starting the bear treatment.
Yes.
Now we can place it in contact with the serum.
Fabrice Bertil meets up with his colleague Etienne Lefay for the next tests. He brings the precious serum, prepared in his laboratory in Strasbourg.
Hi, Fabrice.
Hi, Etienne. How are things?
Good, and you?
Very good. Here are the samples.
Okay, great.
So there you have last year's bear serum.
Yeah?
Summer and winter, along with a detailed list. The myotubes I put directly into the box. Okay?
Okay.
For Etienne and Fabrice, the serum contained in these small boxes may reveal the secret of a bear's strength.
That's it.
Perfect. Time to get to work.
It's the moment of truth. Human cells are brought into contact with this famous bear serum. How will they react?
So here we are on the final set.
Human muscle cells, treated with bear serum.
So here we can see the human myotubes with the summer bear serum,
which are rather long and slender. And here you'll see the difference with the winter serum.
Oh, it's clear as anything. Straight away you notice the difference in size, with much larger cells. We really have a major effect on the amount of protein in the muscle cells. Put the summer cells back. They're
much more slender.
Much more. It's perfectly clear. In fact, muscle cells in the presence of summer bear serum, that's to say when the bear is active, behave quite normally. The real difference is when these human muscle cells are in the presence of winter serum. This is where transformations take place in the cell, and the protein content changes and increases. That's what we need to do to treat people, increase the amount of protein in human muscle. So we can definitely confirm the ability of winter bear serum to prevent the degradation of protein in our human cell model.
Which the summer bear serum is not capable of.
Absolutely.
Such results present the researchers with the major task of identifying which substances in the serum are directly responsible for this action on the muscle cells. They will examine the bear serum with a fine tooth comb, splitting the liquid into increasingly small subgroups and testing it on human cells, trying to isolate the active substances.
Of course, treating people with pure bear serum is not an option. The strategy we are developing entails going through a purification stage, identifying the active ingredients in the bear serum so that they can be incorporated into a therapeutic model to treat either animals or humans who have problems with muscle mass.
Excited by this extraordinary breakthrough, Etienne and Fabrice are already imagining the impact it might have in the discovery of other pathologies.
This is only the beginning, but we've already set up the structure that can test the serum on a set of human cells from different organs.
It involves applying bear serum to human cells from other organs such as the heart, kidneys, and bones. If beneficial effects were to be observed in these cells, it could mean that all organs are controlled by a single substance, one that circulates in the blood of hibernating bears.
We believe that a coordinated system is established during hibernation, one that allows the bear to preserve both muscle mass and bone mass, along with essential metabolic functions, such as cardiac function and renal function. We believe they activate a special protective mode, one that allows them to survive the winter.
In a few months' time, Fabrice, Etienne, and the other scientists will return to bear territory. Once again, they will brave the cold in order to gain a greater understanding of the extraordinary resistance of this fascinating animal.
We celebrated the 50th bear collected in this research program, so we were very happy. 50 captures that went really well.
The close and intimate relationship we can establish with a bear when we study it really is outstanding. We have a deep respect for this mythical animal.
Although their work is only just beginning, they are well aware that this ability to adapt is the result of millions of years of evolution.
It's a question of reading nature in the right way and not giving up. Sometimes tend to forget how much medicine actually came from nature.
The research work of these scientists raises new hopes for humankind and reveals a little more about the strong links that bind us to this animal. Maybe one day, man will have the superpowers of the bear.